Dear students, in the previous episode, we have discussed on the vertical and horizontal distribution of pressure and wind systems. In this episode, we are going to discuss on the air masses and fronts. The episode consists of the following modules: definition and characteristics of air masses, modification of air masses, classification of air masses, fronts, and classification of front. Now, let us see what is an air mass. An air mass is a large body of air with similar temperature and or humidity. Air masses form in stable source regions such as in the subtropics or near to the poles. Study of air masses provides an essential background for understanding the atmospheric disturbances. It brings about changes in day-to-day weather, particularly in mid-latitudes. It plays a dominant role in producing different type of climate. Changes in the weather are the results of the interaction of air masses. Temperate regions in the northern hemisphere are the battlefields in the middle latitudes, where warm tropical and cold polar air mass are brought together. These areas are characterized by cyclones and anticyclones. Air mass also carries large quantity of atmospheric moisture from ocean to continents and to yield precipitation. The concept of air mass was developed by two Norwegian meteorologists, Wilhelm and Jacob, during the First World War. In 1920 to 30, witnessed the development of this concept. It helps to predict weather conditions within 24 hours. Definition and characteristics. Air mass is an immense body of air, usually 1600 kilometers to several kilometers thick, with homogeneous physical properties at any given latitude. The body of air that moves over land and sea surface acquires temperature and humidity characteristics which are uniform in horizontal direction at different levels. Since it may extend through 20 degrees or more latitude, covers hundreds to millions of square kilometers. Since air mass travels an area in several days, the region will have the same weather conditions. Along the margins of the air mass, the weather changes very sharply. When air remains in contact with surfaces for a couple of days, it acquires the temperature and moisture of that area. If the surface is warm, the heat is transferred due to the conduction process. If the surface is cold, the air above will be cooled and heat will be removed, similarly with moisture. The air is always tending to be in equilibrium. Such large uniform surface is called air mass source region. When the air mass moves on the upper part of the atmosphere, they retain the physical properties of the source region as well. Two characteristics of an air mass control the weather. They are vertical distribution of temperature and moisture content of the air. Air mass is associated with planetary wind system. For example, tropical maritime and tropical continental air masses, which are found in the trade wind belts. Therefore, these air masses play an important role in removing latitudinal imbalance of heat. Air mass with temperature lower than that of underlying surface is called cold air mass. Air mass with temperature warmer than underlying surface is called warm air mass. If warm air mass moves from cold land surface to warm ocean surface, it is known as cold air mass. When they come in contact with each other, they do not merge, but they retain the identity. Cold air masses are more unstable than the warm air masses. Source region. Source region are the areas where air masses are formed or originate. The nature of the source region largely determines the temperature and humidity characteristics of an air mass. What makes the ideal source region? So, it must be an extensive and broadly uniform surface. The source region should have a gentle and divergent air flow for a long period of time. Therefore, the regions with high barometric pressure and low barometric gradient are the ideal source regions. Air masses are generally confined to tropical or polar regions. No major source regions are found in the middle latitudes. Tropical Atlantic Ocean, tropical Pacific Ocean, around Hawaii, the Sahara Desert, Siberia is the primary source region. North Pacific Ocean, North Atlantic Ocean between Canada and North Europe, southwest of United States is the secondary source region. Air mass normally migrates from their source region to other regions. They not only modify the weather of the area they move, but they also get modified. When they move from source region, they retain their physical properties. They are uniform in their horizontal extent, but there will be some variations in their vertical distribution also. Modification of air mass. When the air mass moves away from the source region, it will begin to change its temperature and moisture properties to that of the new underlying surface. If an air mass is heated from below, that will lead to instability. If an air mass is cooled from below, stability will increase. For example, when continental polar air masses over the Great Lakes in the late fall, heat and moisture is gained, which results in lake effect snow showers. Air masses also may be modified by ascent and descent. For example, maritime polar moves up a mountain, precipitation removes the moisture. The air mass is more like continental polar on the other side. There are two types of air mass modifications: thermodynamic modifications and mechanical modifications. These modifications may occur either separately or in combinations. Thermodynamic modifications. Thermodynamic processes include such effects as heating from the below, which decreases the vertical stability. The modification of an air mass depends upon number 1, initial characteristics of air mass, that is temperature and moisture, and the nature of the underlying surface, and the path followed by the air mass, and the time taken to reach the point of observation. The air mass moving over a surface that is warmer than the ground temperature is bound to be heated from the below, with the consequent lapse rate and instability. These changes create the changes of condensation and precipitation. On the other hand, an air mass moving over a colder surface is cooled from the below. This condensation favors the formation of surface immersion, which increases with stability of the air mass. It is clear that polar air masses move out of their source region tend to become more and more unstable. The tropical air masses, on the other hand, undergo a second type of modification, develop an increased stability. Letter K and W are used to indicate cold and warm air masses. Mechanical modifications. The mechanical process of lifting an air mass over elevation of land over colder air masses or to compensate for horizontal convergence produces a change in an air mass. Turbulence mixing and the sharing action of wind also causes air mass modifications. The sinking of air from high elevations to relatively lower lands or from above colder air masses and the descent in subsidence and lateral spreading are also important mechanical modification of air masses. Classification of air masses. Physical properties of an air mass determine the weather. Satisfactory classification of air mass must encompass these transitions. Air masses are classified on the basis of location of the source region and the nature of the surface. According to Trivarta, they are polar air mass, tropical air mass, and then they are further subdivided into continental air mass, maritime air mass denoted by letter M, small letter m. Continental air masses originate over the continents and maritime air mass originates on the oceans. Maritime air mass will have large quantity of moisture. On the other hand, continental air mass are originally dry. On the basis of source region, air masses may be of continental polar air masses, maritime polar air mass, continental tropical air mass, maritime tropical air mass, more elaboration classification of air masses. And then wintertime continental polar air mass Cp, summertime continental polar air mass it is Cp, wintertime maritime polar air mass Mp, summertime maritime polar air mass Mp, wintertime maritime tropical air mass Mt, and summertime maritime tropical air mass Mt, and then continental tropical air mass it is Ct. Wintertime continental polar air mass. These air masses have their source region in the central Canada and Siberia. They are extremely cold, dry and stable. Since the surface is covered with snow, these are the coldest wintertime air masses. They create severe cold waves when they move. There are no clouds. They are modified when they move towards warm regions. Summertime continental polar air mass. Source region. Central part of high latitude continents, central Canada, surface heating, absence of snow, cold and dry, not necessarily stable. These are the modified air masses of wintertime continental polar air masses. Heated from the lower layers when continental polar cold air masses move out to oceanic surface, modified into continental polar warm air masses. Wintertime maritime polar air mass. These air masses are cool and moist and from over oceans in the higher latitudes. They are originally continental polar air masses, undergo modifications over oceans. There will be few clouds in their source region. They are dragged into cyclones, forced to ascend mountain barriers, resulting in heavy precipitation. Their lower layers are moist and unstable, dry and cold in their upper parts. Summertime maritime polar air masses. These air masses originate in the source region of maritime polar air masses. They are cool and moist in the lower parts. Temperature inversion takes place. They are stable and general temperature is slightly higher than that of the maritime polar air masses. Wintertime tropical maritime air mass. Their source region is over warm oceans in both the hemisphere. They are warm, moist and unstable. They release abundant precipitation whenever they occur. The moisture is well distributed to high levels. When these air masses are lifted over high mountains, they produce heavy rainfall. Summertime tropical maritime air masses. The source region is on the tropical oceans including the Caribbean Sea. They are very warm, moist and very unstable. The air masses have convective instability. Continental tropical air masses. They originate at the subtropical high pressure belts. They have high temperature and low moisture content. They do not spread extensively beyond its source region. In United States, they are dry in both seasons. In summer, they are very hot and they produce thunderstorms or tornadoes. Fronts. In the previous section of this episode, we have seen that air masses move with a general circulation of atmosphere. They differ in their temperature and moisture content. They also differ in their pressure and density. When two different air masses with sharp contrast in their physical characteristics, temperature, pressure and density resulted in the general circulation, the front occur. They do not mix easily. In fact, they come in contact with one another along sloping boundary. Fronts are the transitional zones. Weather conditions within the air masses are comparatively uniform. There is a discontinuous change in the weather elements. The front is synonymous with the line of discontinuity. It is the transitional zone between two air masses with a different density. The front is given by the Norwegian meteorologist, borrowed by analogy from the military front during the First World War. Since the air mass are three-dimensional, vertical as well as horizontal extents, frontal source may be defined as a three-dimensional transitional zones between contrasting air masses. Air masses may be vast in size, covering tens and thousands of miles. In the narrow frontal zones, there will be an abrupt change in temperature, pressure and humidity. Within 3 kilometers, sometimes there will be a change in temperature between 10 to 20 degrees Celsius. General frontal characteristics. Fronts differ in their types, location or aerial extent. Temperature. There is a large difference in temperature across front. Change may be abrupt or gradual depending upon the nature of the opposing air mass. Larger the difference in temperature, thinner the frontal zone and vice versa. Air pressure. Generally, the isobars in a given air mass are smooth curves and there are no sharp bends. The bend is always towards the direction of low pressure. Wind. Wind movement is always controlled by the pressure gradient and Coriolis force. Therefore, the wind always blows from higher to lower pressure, crossing the isobars at an acute angle. Cloud and precipitation. Frontal activity is invariably associated with the cloudiness and precipitation. Since warm air moves up along the frontal surface, it cools adiabatically, which results in cloudy condition and precipitation. Clouds formed on sloping frontal surface extend for hundreds and thousands of kilometers. Upward moving warm air above the wedge or cold and dense polar air mass, it is from these clouds that precipitation occurs. Frontogenesis and frontolysis. Tor Bergeron used the term frontogenesis, Latin meaning creation of altogether new fronts or regeneration of declining fronts already in existence. When contrasting air masses have convergent movement, the frontogenesis occurs. The temperature contrast in the converging air mass is another important prerequisite for the process of frontogenesis to occur. The fronts come into existence only when the above two conditions are fulfilled simultaneously. In other words, the convergence of air mass with different temperature and densities is conducive for frontogenesis. Classification of fronts. They are cold front, warm front, occluded front and stationary front. Cold front, it is a front along which cold air is invading the warm air zone. Since the colder air is denser, it remains at the ground and forcibly uplifts the warmer and lighter air masses. The zone of transition is called cold front. The steepness of the front is closely related with the velocity. Higher the velocity, the greater the slope. When the cold front moves over a rough terrain, the lower air is retarded by the effect of friction at the ground. If the cold air moves over a warm water surface, the lower air absorbs heat and moisture, which results in heavy rainfall. Cold fronts are marked on weather maps as a blue line with blue triangles pointing in the direction of movement. Temperature and humidity quickly drops after the cold front passes. A decrease in pressure is also observed before the front and an increase afterward. Winds ahead of the front blow southwesterly, while winds behind the front blow northwesterly. Lifting of warm air along the cold front is pronounced. Precipitation tend to be showerly due to the cumulonimbus clouds and limited to near the front itself. Travel faster than any other kind of front. Warm front. It is a generally sloping frontal surface in which there is an active movement of warm air over cold air. The warm air occupies the territory of formerly occupied by the cooler air. Unlike the cold front, the changes in temperature and wind direction are gradual. Warm fronts usually yield moderate to gentle precipitation over a relatively larger area for several hours. Marked on a weather map as a red line with red semicircles pointing in the direction of frontal movement. Temperature and humidity increases after frontal passage. Front is located in a region of lower pressure than the surroundings. Winds ahead of the warm front are easterly, while winds behind the front are southeasterly. It has a greater slope than cold front. Warm air cannot push the cold air in front of it out of the way. The height of the clouds decreases as the front approaches. Occluded front, defined as front formed when cold front overtakes a warm front. Cold front moves more rapidly when warm front, with the result warm front progressively reduces in size. Ultimately, the cold front overtakes the warm front and completely displaces the warm air at the ground. Finally, the cold and the warm front combine into one. Occluded fronts are marked on a weather map with a purple line containing alternating warm and cold front symbols on the same side of the line, indicating the movement of the front. Because warm fronts travel slower than cold fronts can overtake warm fronts. When this happens, the warm air is forced aloft as cold air surrounded the low pressure. A cold occlusion results if the cold air behind the cold front is the coldest air on the map. A warm occlusion results if the cold air behind the front is warmer than the cold air ahead of the warm front. Stationary front. There are situations where the surface position of the front does not move. Therefore, such a front is called a stationary front. The wind motion on either side of such a boundary is parallel to the position of the front. Stationary fronts are marked with a line containing alternating warm and cold front symbols, showing the way the warm air or cold air would move if it could. Little or no movement of the frontal zone occurs at the surface. The air aloft will usually be overrunning, producing clouds. Weather conditions are usually similar to a warm front, but milder. The extended periods of cloudiness and light precipitation can develop along the cooler air. In brief, an air mass is a large body of air whose properties of temperature and humidity are fairly similar in any horizontal direction. Source regions for air masses tend to be generally flat, of uniform composition, and an area of light winds dominated by surface high pressure continental air masses form over land. Maritime air masses form over water. Polar air masses originates in cold polar regions, and extremely cold air masses form over Arctic regions. Tropical air masses originates in warm tropical regions, and continental polar air masses are cold and dry. Continental Arctic air masses are extremely cold and dry. Continental tropical air masses are hot and dry, and maritime tropical air masses are warm and moist. Maritime polar air masses are cold and moist. A front is a transition zone between two air masses of different densities. The density contrast results from differences in temperature and humidity. The frontal zone is the upward extension of the front. Sometimes the frontal zones can be very sharp. The density of the weather along the front depends on the contrast of the air mass properties. The type of front depends on both the direction in which the air masses is moving and the characteristics of the air mass. Air masses and fronts have served as a background for a clear understanding of atmospheric disturbances. Tropical cyclones and anticyclones offer some of the best examples of such disturbances. In the next episode, we will be discussing on tropical and temperate cyclones.